With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, the question is, which gas will be evolved out when primary amine is treated with sodium nitrite and HCl? Okay, so here we need to tell which gas will be evolved when we treat our primary amines with sodium nitrite and HCl. Okay, so your options are chlorine. So chlorine gas is what? It is Cl2, right? Ammonia is NH3, and nitrogen is N2, and NO2 is, you know, that nitrogen dioxide gas. Okay, so now let's see here. What is given in the question? We are treating we are treating primary amine with NaNO2, that is sodium nitrite and HCl. So let's take an example of primary amine. Let's take the example of ethylamine, that is CH3, CH2, NH2. This is our what? This is our ethylamine, right? So this is primary amine. Why this is primary amine? Because this nitrogen is attached to one carbon and has two hydrogens on it, right? It has how many hydrogens? Two hydrogens, and it is attached to one carbon. So thus this amine is known as what? Primary amine. So when we treat this primary amine with NaNO2 and HCl, NaNO2, that is your sodium nitrite, plus HCl at 0 to 5 degrees Celsius. See, we know that this is a diazotization kind of a reaction, right? Because there also, when we treat our aniline with NaNO2 and HCl, what happened? Diazonium chloride salts are formed, right? And how it is, what happens here with NaNO2 and HCl? We know that NaNO2 and HCl on conversion, on reaction, they give HNO2 plus NaCl. Okay, so they give us nitrous acid. So basically so that's why we use it separately, because nitrous acid is what? It is not stable. Okay, so that's why we will make it in situ. That means in the reaction. So by adding NaNO2 and HCl at 0 to 5 degrees Celsius. Okay, so thus this will convert this primary amine into what? This will also convert this primary amine into a diazonium chloride. Alright, so what you will get when on this reaction, you will get this CH3, CH2. Okay, you will get N2 and Cl minus, right? So it's like this, N triple bond N. Here you get N, this again N gets positive charge and a Cl minus. Okay, and a Cl minus. So you will get this ethyl diazonium chloride, right? This is what? This is, okay, now let's see the mechanism. See, this is our HNO2, right? HNO2 is this, ON, single bond O, H. This is our HNO2, H and O2. Okay, so here oxygen has two lone pairs, right? We are treating it with acid. Okay, acidic medium is there, so H plus will come from there. Okay, and Cl minus will also be there in the medium. But right now, what will happen? Protonation will take place of this oxygen. It will attack on this hydrogen like this, and what we will get? We will get protonation like this. Protonation will occur on this nitrous acid like this, and you will get a positive charge here. Okay, now water can be removed easily. So what will happen? Water will remove, minus water, and what we will get? We will get nitrosonium ion, that is O double bond N with a positive charge on nitrogen. This is our nitrosonium ion. This is our electrophile, nitrosonium ion. Okay, now what will happen in the next step? Our ethylamine, that is CH3, CH2, NH2, right, will go and react with this nitrosonium ion, that is N double bond O. N has a positive charge. N has a lone pair, right, will attack on nitrogen, which is having a positive charge like this, and what we will get? We will get, let's write this whole molecule CH3, CH2 as R. Okay, let's write here R is what? R is ethyl group, that is CH2, CH3. Okay, I'm just letting this as R so that it will be easier for you to understand what is happening in the reaction. Okay, here this is R. Okay, and then this NH2 is having two hydrogens, right? With this nitrogen formed a bond, nitrogen double bond O. Now because this nitrogen got 4 bonds, it will get a positive charge, right? Now the next step, what will happen? H plus will be removed, so that this plus charge can be neutralized, right? And what we will get? We will get this R N single bond H, N with double bond O. Okay, now what will happen in the next step? Proton transfer will take place, right? H plus transfer, that is proton transfer will take place. What will happen? This bond will go here, this will go here. When this will go here, O will get what? A negative charge. This negative charge will attack on this hydrogen. Okay, proton transfer is taking place like this, and what we will get? We will get this R, N, double bond N, OH. Okay, again, oxygen has what? 2 lone pairs. Protonation will take place here. H plus, right? It will attack on H plus, and we will get this will get protonated, and we will get R, N, double bond N, OH, H. O will get a positive charge. Again, water will remove, right? Water will remove, minus water, and what we will get? We will get this R, N, double bond N, where this N, because electrons are going towards oxygen, this N will get a positive charge. Now, nitrogen has a lone pair, right? It will attack, it will give its electrons lone pair like this, so that the octet of this nitrogen will be completed, right? So what we will get? We will get this R, N, triple bond N, and this will get a positive charge like this. Okay, which can also be written like this. Okay, because this is having a positive charge, a counter ion will come here, that is Cl minus. Okay, which I wrote above, and I told you that here. Okay, because acid is there, and Cl will also be there in the reaction, because we have added HCl, right? In the reaction mixture, we have added HCl with NaNO2. So Cl minus will be there. So that Cl minus will come as a counter ion here and will form like this, which can also be written if I write R as ethyl group, because I have let R as ethyl group. We will write it like this: CH3, CH2, CH3, CH2, N, triple bond N, positive charge, and here Cl minus. Okay, and this as can also be written as I have written in the reaction. It can also be written like this: CH3, CH2, N2 positive, Cl minus. Okay, so now let's see the further reaction. Okay, this is what? This is ethyl disonium chloride. Okay, so what happens is, now later on we treat it with water molecule. When we treat it with water molecule, what will happen? See, this Cl minus is just there because of the ionic attraction with the N positive. Okay, what happens is, this water molecule attacks on this carbon. Okay, attacks on this carbon, and this is removed like this. And we know that N2 gas, okay, whenever there is a possibility of removal or evolving of the gas, that reaction is that is the driving force of that reaction. Okay, so since here N2 gas, nitrogen gas will be able to remove, so that's why this is the driving force. Water oxygen will go and attack on this carbon, and this will leave. Okay, so what we will get? We will get this CH3, CH2, OH2 like this, and oxygen will plus charge, and plus what? N2 gas will be evolved. So here N2 gas is evolved, and later on in this molecule H plus will be removed, right? Minus H plus will take place, and thus we will get what? We will get our ethanol, CH3, CH2, OH. So thus we will get this ethanol molecule, and here nitrogen gas is evolved. So in this process, whenever we treat primary amines with NaNO2 and HCl at 0 to 5 degrees Celsius, which gas is evolving? N2 gas, that is nitrogen gas, is evolving. So your options: chlorine is incorrect, ammonia is incorrect, nitrogen is correct, and NO2 is incorrect. So thus your option C is the right answer. I hope you understood. Thank you so much.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.